So the question says, the question is this, and it is a past FRM examination question. Okay, so there is one husband and wife. So there is one husband and wife. Okay, and husband has gone abroad. Let's say husband has gone to another city to work. Okay, so husband has gone to another city to work. Okay, and they are communicating through letters. Okay, that is not through emails but the letters. Okay, the snail mail letters, they are communicating through it. That, okay, now what has happened is the postal system of the country is not good. The postal system is not good. The probability that a letter will get delivered is 0.6. The probability that a letter would get delivered is 0.6, and the probability that a letter will not get delivered will be mutually exclusive, so 0.4. Okay, now husband has written letter to wife. Okay, husband has written letter to wife. Okay, now if wife receives the letter, okay, she will definitely reply. Okay, so she will definitely reply. If wife receives the letter, she will definitely reply. Okay, the question is, if husband wrote the letter, so husband wrote the letter but did not get the response. So husband wrote the letter, he did not get the response. Okay, find the updated probability. Find the updated probability that wife and please note that this is like exact the question like it has come in the examination. Okay, nothing else was given. Okay, so what you know is the probability that letter would not be delivered in that country because of bad postal system is 0.6. Okay, husband has written letter to wife. Okay, so husband has written letter to wife, and if the wife receives the letter, she will definitely reply. Okay, husband wrote the letter. Okay, but he did not get any response. Okay, you have to find out the probability that wife received the letter, and you have to find out the what they have said is updated probability. So you have to find out the updated probability that wife received the letter. So this was your 1 mark question. So first of all, what is the probability? I am not saying that updated probability. I want to know what is the probability that wife received the letter. First, when husband wrote the letter, what is the probability that wife received the letter? 0.6. Can I say 0.6? Because the postal system is bad. So when husband wrote the letter, wife would have received the letter 0.6. So let's take the scenario. Okay, and I have said that please take, so if you see over here what I said in the last, that whatever you want to find out, the updated probability that wife received, okay, so please keep that in the left side. Okay, and whatever is given, you take it in the right side. So what happened is the husband did not get the response. So we are sure that husband did not receive any response. Okay, we will take it in the right side. So think about, we have a scenario, husband getting the letter, so husband getting the response, husband not getting the response, husband getting the response, and husband not getting the response. Okay, and we have a case over here where wife receiving the letter, wife not receiving the letter. If you are able to come up with this, okay, you will be surely be cracking this problem. Okay, so what we know is, what is the probability that wife received the letter? Okay, you said that it is 0.6. So what we have is, okay, I will erase this. Okay, so what we have this scenario that probability wife received the letter is 0.6. Probability wife did not receive the letter is 0.4. Okay, now because the postal system is bad. Okay, now when wife receives the letter, can I say that she will definitely respond? We have said that when wife receives the letter, let's say we have another node we are trying to create. Okay, let's say when wife receives the letter, she will definitely respond. That is, response probability is 1. Okay. Now when wife has sent the response, okay, it may happen that again the postal system is bad. So probability that husband will get the letter is, can I say again it will be 0.6? Can I say that? Because postal system is not good. And probability that husband will not receive the letter will be 0.4. Right? Now take the case when the wife did not receive the letter. Will she respond? If she did not receive the letter, she will not be knowing that whether she received the letter or not. So the probability that she did not give the response is 1. Okay, and when she did not respond, obviously the husband will not get the letter. So can I say that the probability that husband will not get the letter will be 1? These are all your conditional probability. Okay, all of these are conditional probability. Okay, can I say that this is the tree diagram will look like? Okay, now we can make a better tree diagram. Okay, and over here we can say that probability of wife receiving 0.6, probability of husband receiving given wife received is also 0.6. So this is your node 1. Okay, and then probability of husband not receiving given wife receive is 0.4, and this is your node 2. Okay, then probability of wife not receiving is 0.4, and the probability that husband will receive given wife not received is 0, and probability that husband will not receive given wife not received is 1. Okay, so we have node 3 and we have node 4. Okay, now over here we have said that husband did not receive the letter. So husband did not receive the letter. So which are our which are the nodes where husband is not receiving the letter? Husband is not receiving the letter in which all node? Can I say 2 and 4? So node 2 and 4 are the nodes where husband is not receiving the letter. Okay, and we are interested in finding out. So what was the question? If the husband did not receive the letter, find out the probability that wife received the letter. So what is our favorable node? So favorable node is what? So which is our favorable node? Can I say that 1 is our favorable node? Because wife, we said that husband did not receive the letter. So it can happen in not node 1, but it will be node 2. Sorry. Can I say that husband did not receive the letter? Here and here it will be the case 2 and 4. Okay, and husband did not, wife received the letter is this. So which is coming in node 2. So favorable case is node 2, and as a result the updated probability will be given as node 2 divided by node 2 plus node 4. Now it boils down to finding out what is the probability of node 2. Probability of node 2 is 6 into 4, 24. So node 2 is 24. What is the probability of node 4? 0.4 into 1. So 0.4. So the answer will be 0.24 by 0.64. So this is the answer. Okay, and this is your actual examination question. Okay, if you solve this, 6 for the 24, 16. So 16 6 are 96. So it will be 6 6 36 and 38 around. So it will be 0.38. So the probability will be 0.38. So wife received the letter, the probability before the fact was 0.6, after the fact it is 0.38. Okay, getting the idea? That means if husband did not receive the letter, it most likely it would have happened that wife did not receive the letter, because wife is very certain of responding. Okay, so what we have is updated probability is very different than the priori probability. So this is your priori probability and this is your posterior probability or updated probability. Updated probability takes into the scenario with the updated case. So things have changed, and so what will happen in this earlier setup. Okay, so you have Bayes theorem. So this is the probability of event given information. So I will say that do not remember this formula. Okay, you should be able to follow the formula. Okay, using the drawing the tree diagram and then following the node. So this is one example which I have given. Don't worry, you have solved a difficult one. Okay, if you want, you can solve this. Okay, now let's try to cover the other concepts, that is the probability function. Remember, like that time we said that okay, probability function is somehow like a distribution. Okay, so probability function, it specifies the probability of a random variable taking a specific value. So the probability function we are specifying by px. Okay, so remember, like we denote function by fx. So for a probability function we will use px. So it is denoted by px, and for a discrete case we'll say that p, what is the probability that x will take a value of. So this is note that. Okay, so let me erase this. So what we are saying is this probability is denoted as this px, and it is written as px equal to small x. That is what is the probability of, when you are throwing a die, what is the probability of node 1 coming, okay, of not node 1 but number 1 coming. So we say that it is written as probability x is equal to 1. Okay, now a probability function also follows the same property that the probability follows, that is any probability function cannot be less than 0 or greater than 1. It has to be between 0 and 1, both inclusive, and summation of the probability function should be equal to 1. So this comes from the properties of probability. Okay, now we have seen that the variables can be of two types, that is the discrete random variable and continuous random variable. Okay, when you are using a discrete random variable, so for a discrete random variable, the probability function is known as probability mass function. Okay, it is called as a mass function. So if you want to find out if let's say I denote the probability of a throw of die, okay, so this is your probability and these are your number x. Okay, so we can have the situation when x is 1, 2, 3, 4, 5, 6. Okay, if you want, what I will say is what is the probability of 1 coming? Okay, so this will be 1 by 6. What is the probability of 2 coming? 1 by 6. Probability of 3 coming? 1 by 6. 4 coming? 1 by 6. 5 coming? 1 by 6. 6 coming? 1 by 6. That means for all the numbers the probability is same, and this is the diagram of the probability function. Okay, and it will be written like this: probability of x equal to, so if we write what is the probability of 1, p1 equal to probability x will be taking a value of 1 and it will be taking a value of how much? 1 by 6. So all the numbers over here will be the same because this is how we have probability. So this particular case is your uniform function. So because all the outcome have the same probability, so here we are saying it is a uniform function. However, it is not necessary that it should be a uniform function. Okay, so we can have different cases over here. So here it was coming as a uniform function. Okay, so for a discrete random variable, the probability function is known as probability mass function. When the random variable is not discrete, it is called as continuous random variable, then the probability function is called as a probability density function. Okay, please note that there's a difference between the probability mass function and density function. Okay, in probability mass function you are having probability in the y-axis and you have numbers in the x-axis. However, in a probability density function, what we have is, okay, in a probability density function, let's say we are trying to come up with some, let's say something is there, some density function is there. Okay, let's say we are coming with some value between let's say 2 to 3. Okay, we have this is a probability density function. On the y-axis you have frequency, on the x-axis you have number. Okay, we will come to I will give you some example. Okay, and the probability is not given by the y-axis. The probability is given by any idea how we'll define the probability? The probability is defined as the area. So if whatever is the area of this item, okay, so this is the probability. So area will determine the probability. So what is the total area? So if you see, total area will be all this sum. So this pink color, the total area will be how much? What can be said about the pink color, which is the area? Can I say it will be 1? because it is the total area. The total area has to be 1. Okay, and this black one is the probability that number will be between, let's say, 2.7 to 2.8. Okay, so that is the black one. Okay, now I will give some example. Let's take some example of both of these so as to understand this in slight detail. Okay, so let's say I denote a probability function. What is happening? Let's say I denote a probability function. Fx is equal to, okay, x. We are saying that fx is equal to x. Okay, when x is between 2 and 4. Okay, or maybe think simple. Okay, fx is equal to, okay, let's make it x only. When x is between 2 and 4, okay, and fx is equal to 0 otherwise, that means when x is less than 2, fx is 0, and also when x is greater than 4, fx is 0. So this is our fx case. So if you try to draw the diagram of this fx, what will happen? Okay, so this is our fx and this is the value of x. If I want to draw this diagram, how it will become? Can I say that up till 2 it will be 0? Okay, so up till 2 it will be 0. Any time after 2 it will be, any time after 4 it will be 0. Between 2 and 4 it is equal to x. Okay, or for your matter, let's say, okay, let's say it is 2. Between 2 and 4 it is 2. So 2 will be, let's say here 1 and here we have 2. So between 2 and 4 it is 2. Okay, so this is your function. Okay, between 2 and 4 its value is 2. Okay, and I want to understand how we will represent this in the form of probability function. Okay, so this is probability function, how I want to denote. Okay, so what we say is, okay, this number can exist between only these two numbers, 2 and 4. Can it exist beyond this? It is not capable of existing beyond this, right? So what we say is between 2 and 4 it is only existing. Okay, and it is a kind of a uniform function because between 2 and 4 it is uniform. So what we say is, okay, from the probability point of view, can I say that the probability that, so correct me if I am wrong, what is the probability that x will be between 2 and 4? Can I say that the probability that x will be between 2 and 4 is 1? Right? It will be area under the graph. Can I say that x is 0 beyond? X is 0 over here, x is 0. X is existing only between, so the function is existing only between 2 and 4. Okay, so this is the only space where it is existing. It has no existence, so fx has no existence between, so probability that fx has no existence beyond 2 and 4. Okay, so what is the probability that x is between 2 and 4? This is the only universe space for it. Can I say it will be 1? Okay, now I asked you what is the probability that x will be between, okay, x will be between 2 and 2.5. So think about this x between 2 and 2.5. So here 2 and it is 2.5 over here. Okay, so what you have is that part is this area under this between 2 and 2.5. Okay, so what you have is total area is 1. We know that total area is 1. The area under this part will be, so what we can say is total area is how much? Let's say this is width 2. Okay, and this is also 2. Okay, so 2 into 2 is equal to 1. Okay, but here we are interested in 0.5 into 2, so we can say that 4 times is 1, or so this will be 0.25. Can I say that the probability that the number will be between 2 and 2.5 is equal to 0.25? Okay, correct me if I am wrong. Okay, it will be 0.25. Okay, so you can find out the area. So area is 0.5 into 2, which is 1. So 4 times 4 was equal to 1. So 1 is equal to 1 by 4. Okay, so that way we can say 0.25. Now I ask you one quick question. What is the probability that x will be between this? That is, here I had equal to, here I am not having equal to. What is the probability that 2 is less than x is less than 2.5? So I have three options for you. Okay, will it be greater than 2.5, 0.25? Will it be equal to 0.25? Third option will it be less than 0.25? Fourth option is can't determine. Okay, so these are the four options. This will not be less than 0.25. Okay, because over here, can I say that what type of distribution it is? Is it a continuous distribution or is it a discrete distribution? It's a continuous distribution, right? Now between 2 and 4, how many numbers are there? Infinite, right? So can I write this probability? Can I write this probability as probability that x is equal to 2 plus probability that 2 is less than x is less than 4 plus probability 4 that x is equal to 4. Can I write this way? Probability that x is equal to 2 plus probability 2 less than x is less than 4 plus probability x is equal to 4. Can I write this? This same thing I can write this way. Correct me if I am wrong. Okay. Or for that matter, can I write this way? That is probability that x is equal to 2 plus probability that 2 is less than x is less than 2.5 plus probability x is equal to 2.5. Can I write this? Now, what is the probability x is equal to 2? What is the probability that x will be equal to 2? Okay. Going back to the definition of probability, probability is equal to favorable case by total case. Okay. What is the favorable case over here? Favorable case is only 1 point I have. What is the total case? I have infinite points. So that means probability of x being 2 is 0. Same way, can I say that the probability of x being 2.5 is also 0? So this is 0, this is 0. What can be said about this then? Can I say that this and this are same? So can I say that the probability that 2 is less than x is less than 2.5 is equal to this number? So can I say that answer should be B? Okay, so what we have is, in case of continuous distribution, you will be seeing that probability of A less than x is less than B is equal to probability of A less than x less than B is equal to probability A less than x is this, and so all four are same. So these all four are same because probability of one item is 0 because there are infinite possibilities. Okay, so that means if you want to find out the probability of one number, it will be 0. However, if you are interested in finding out the probability can be found out through area. If you are interested in finding out the probability between any two numbers, we'll say that the area will give you the probability. This is a very important conclusion for us, right? So in case of density function, the way it is like it's a density. Okay, so remember, like density like volume. Okay, however here like the volume, instead of volume we have a density function for area. Okay, and if you want to find out the probability will be given through area. Okay.